So this one is a pop quiz 3 which was related to bonding and the moles. So in the first question, fluorine and chlorine are halogens, suggests the appearance of a fluorine. So fluorine is light yellow or pale yellow. So, and chlorine is yellowish green. So they ask for fluorine, so it will be a pale yellow. Then we have a fluorine react with sulfur to form a compound which contain 25.2% sulfur by mass and with a molecular mass of 254. Determine the molecular formula. So fluorine is reacting with sulfur, and it contains 25.2% sulfur. So if 25.2% sulfur is there, how much fluorine is there? Because the total percentage, so this will be 74.8% fluorine will be there. Now, first what we do, we work out the empirical formula, and then from empirical formula, we work out the molecular formula. So first step is step 1, we divided by the relative atomic mass. So sulfur is 32 and fluorine, because it's relative atomic mass, so we divide mass of atom, and fluorine is 19. So 25.2 divided by 32, it's the answer. 0.7875. And 74.8 divided by 19, that is 3.93. Then the second step, what we do, we divide by the smallest value in the combination. So which one is the smallest value? 0.7875 is the smallest value. So we divide both of them by 0.7875. So this will be 1. This will be 1, and 3.93 divided by 0.5. Okay. So what is the empirical formula now? Like this give us an empirical formula. So empirical formula is SF5. 1 sulfur and 5 fluorine. Like the simplest ratio is 1:5. But the question is about the molecular formula. So how to find the molecular formula? Molecular formula is empirical formula times N. And what is N here? N is a molecular mass divided by empirical mass. So the empirical formula is SF5. What is N? N is a molecular mass. The molecular mass is 254 divided by empirical mass. How to work out the empirical mass? Empirical mass you can find from empirical formula. Here we have sulfur, which is 32, and we have fluorine, which is 19 multiplied by 5. So this will be 127. So when you divide, this will give us 2. So this is SF, and then a bracket 2 is there, because when we divide them, we get 2. So this 2 will be multiplied with sulfur, and this 2 is multiplied with fluorine. So the final answer will be S2 and F10 will be there. That is the molecular formula of this compound. So whenever they ask molecular formula, there are different ways. If sometimes structure is given, so you count the number of atoms of each element, and then that will be the molecular formula. But what if percentages are given to you or the mass is given to you? So first you have to work out the empirical formula, and from empirical formula and the molecular mass, use to find the molecular formula. In part C, nitrogen trichloride NCl is a covalent compound. Covalent compound is formed by sharing of electrons. So you have to draw the outer shell electrons only. So nitrogen, which group it belongs to? It belongs to group 5. When element belongs to group 5, how many electron it will share? Group 5 will share 3, because it need octet 8. So 5 plus 3 makes 8. And how many unshared? Because out of 5, 3 are used, so unshared will be 2. Chlorine belongs to group 7. Group 7, how many need to complete octet? 1, so it will share 1. And how many unshared will be there? 6 unshared electron. So here what will happen? Nitrogen, like we start with the one which is surrounding. So chlorine share 1. If chlorine share 1, nitrogen share 1. Chlorine share 1, nitrogen share 1. Chlorine share 1, nitrogen share 1. An unshared electron on chlorine, there should be 6 unshared electron on each chlorine you have to draw. Where nitrogen belongs to group 5, so it shares 3, so unshared will be 2. So this is a covalent structure of nitrogen trichloride. In part D, lithium chloride is an ionic compound. Look, what you will find a difference here, that when they ask for a covalent compounds, they usually ask for the last shell electrons only, the valence shell. But when they ask for ionic compound, you have to draw the structure of the complete ions, means inner shell electrons as well. So lithium chloride is an ionic compound. We have to complete a dot and cross diagram. So when you check the periodic table, you'll find lithium is proton number 3. So if you were having a lithium atom, if there was a lithium atom, the first shell it will have 2 electrons and the second shell it will have 1 electron. And when we have a chlorine atomic number is 17. So the configuration will be 2, 8 and 7. So 2, 8. So means there is a third shell should also be there, and that should have 7 electrons. So what happened in ionic compound? In ionic compound, there's a complete transfer of electron. So metal will lose its valence shell electron, and that is being transferred to the non-metal, which will gain that electron and complete the octet. So because sodium is losing 1 electron, so there will be a charge of 1 plus or plus 1, and chlorine gains 1 electron from a chloride ion, so the charge will be minus 1. So it's important that, so remember, for ionic compounds, whenever they ask for ionic compound, you have to show the whole structure, inner shell and outer shell. If you don't draw this outer, because this electron is being lost, so if you don't draw this shell, that's also fine. If you draw the second shell and show empty, that's fine. If you don't draw, that's also correct. Explain in terms of attractive forces between particles why lithium chloride is solid at room temperature, but nitrogen trichloride is liquid with a relative low boiling point. So the intermolecular force, first thing, what will happen? Lithium chloride is ionic compound is there. LiCl is ionic compound. So it has strong electrostatic attraction between oppositely charged ions. Then what about the nitrogen trichloride? The nitrogen trichloride, the NCl3, is simple covalent compound. So weak force between the molecules. Weak force is there between the molecule. So less energy is needed to separate the molecules. That's why it has a low boiling point. So whenever they refer anything to a boiling point, you should always use the term energy. Is it clear, this one? So this was a pop quiz which was related to bonding and modes. Now we'll start topic organic chemistry as we stop about the structures.